Hello and welcome back. In the last video, we learned about the different kind of storage that's available in Proxmox, and in this video, we'll look at another kind of storage, which is ZFS. And here we'll show you how to create a mirrored ZFS disk, how replication works, and how to replace a corrupt disk if something goes wrong. Alright, so let's take a look at ZFS. And I have two empty disks on each of my nodes, so I will be using these to create a ZFS volume. So on PM1, we'll go to Disk, and then ZFS, and here we can click on Create to create our first ZFS volume. And the ZFS creation window, it does give us a bit more options compared to when we created our directory and when we created our LVM storage. I can see all my available storage media, and I will select both /dev SDB and /dev SDC. I will name my storage ZFS-PM, and we'll leave the option to add storage. Now this is where ZFS shines. We have these RAID features. With LVM, we were able to group our hard drives together to increase our storage. However, in that situation, if one of our disks fails, then we will lose our data. With ZFS, we can create redundant storage. So I will create a mirrored storage. And with the mirror storage, this will write identical copies of the data to both of my drives simultaneously. So which means that if one of my drives fail, my data is still safe on the other one because the data is duplicated. Now you do sacrifice half of your storage capacity for this redundancy feature. So because I have two 100 gigabyte storage media with mirroring, or it's called RAID 1, I will only have 100 gigabyte of storage. And for our compression, I will choose LZ4, and this is a fast, lightweight compression used mainly with ZFS to reduce disk usage while keeping really good performance. It can compress your data on the fly, it can save space with minimal CPU impact, so this is perfect for VMs and containers. Now, A-shift in ZFS, it basically defines your block size used on a disk, and it usually matches the modern 4K drives. So setting this correctly will improve your performance, and it could prevent wasted space as well. Now, it cannot be changed after you created your pool. Now, you can leave A shift at 12 because that will align ZFS with the modern 4K, which is 4096 byte disk. And once I'm done with my configuration, I will select Create. Next, I will do the same thing for PM2. I will choose the same options as I did with PM1, including the same name. And then we'll click Create on that as well to create it. And now we'll do the same thing for PM3, but this time I will name it ZFS-PM3, but I will keep the other settings. Now I will go to Data Center and then Storage. And here I will edit ZFS-PM, and we can see that my current nodes are PM2 and PM1. Now since they have the same name, Proxmox will group them together. And I can check the box to enable thin provisioning. So when we create our virtual machines, Proxmox won't assign the entire storage we give the virtual machine. So I will click OK here. And then I will edit PM3. And we can see this ZFS volume is only assigned to PM3. And I will enable thin provisioning here as well. Alright, so let's do some testing with ZFS. I will create a new virtual machine. So I will pause the video here, and I will resume once I'm done. Okay, so my Alma Linux VM has been created. So first we'll go to my ZFS storage media. And we can see that ZFS only allows us to store VM and container data. So there's no backup and there's no ISO media. And then I will click on my VM disk next. And here is the VM disk for my Alma Linux VM. It's stored in a RAW format, and this is the only format that's available with ZFS. Now I will shut down my Alma Linux VM. And then I will go to hardware, and here I will remove the DVD drive. And I'm doing this because I'm going to migrate my VM. And usually the DVD drive will cause issues, so make sure that you do that beforehand, or else it will warn you that you have a DVD drive attached to your VM and you need to remove it. So now I will click on Migrate, and the target node is PM2, and we do get a few warnings that the migration might take a while. Now, if I were to change this to PM3, we'll see the error message that we're not able to migrate to this volume, because ZFS-PM is not available on PM3. The ZFS storage for PM3 is ZFS-PM3. For now, we'll migrate over to PM2. And just a reminder, ZFS only supports offline migration. So if this VM was online, ZFS would power it off before the migration. And we'll give it some time, and there we go. The virtual machine has been successfully migrated over to PM2. And we can turn it on to confirm that it is indeed working. So although PM3 is within our cluster, with the ZFS resource being a different name, we're not able to utilize it to its full capabilities. So what I will do is delete the current ZFS resource and recreate it. And we can do that by going to the current PM3 node, and then under this, we'll click on ZFS, and then we'll click on this storage resource, and then we'll click on More, and then Destroy. We'll ensure both boxes are checked, and then we'll enter the ID, ZFS-PM3, and we'll click on Remove. Now this method works for any disk, so whether it's a directory storage or LVM storage, you can delete your disk this way. Now we'll create it one more time, and this time we'll use the same name. And once again, I will power off my virtual machine. And if I were to try to migrate this VM one more time, we can see we now have the option to migrate this VM over to PM3. So I will migrate this VM over to PM3. And we'll start it again just to make sure that it is working. All right, next we'll look at snapshots. So on my Alma Linux VM, I will take a snapshot of the current state. I will name it Fresh Install. Then I will click on Take Snapshot. And then I'll head over to my Alma Linux console. And I will log in. And now I will do a quick IPA just to see what my IP address is. And then in terminal, I will SSH into my Alma Linux VM. And then I will type this command. Now don't type this command until you see what it does. Now what this command will do is basically zero out my hard drive, so it will take up all of the space. Now if I try to update my repository, we'll get this wall of error messages, and it's basically telling me that my disk is full. And that makes sense because I just zeroed out my disk. Now this is a problem because I now cannot update my repository, which means I'm not able to install any software either. So let's roll back our snapshot. Back in the GUI, we'll head back to Alma Linux snapshots. We'll click on Fresh Install and roll back. Now we'll head back to our terminal, SSH into Alma Linux VM, and now we'll try to update our packages. And there we go, it's now working. So you can see how a snapshot can save you if something bad were to ever happen. But this only works if I take the snapshot beforehand. You could use backups to automatically take snapshots for you as well. And the last feature that I want to show with ZFS is replication. So I will click on the replication tab for my virtual machine. And here we'll add a new replication job. The target node will be PM1. We can change the schedule, but I will leave it for every 50 minutes. And I will leave everything else as is. And then I will click on Create. And then we'll wait for the schedule to run. And once that is done, this will create a copy of my Alma Linux disk on PM1. So if we click on the ZFS resource on PM1, we can see the EFI storage disk, the VM storage disk, and even the snapshot was copied over. And just a reminder, for the replication to work, you do need to confirm that the high availability service is running for the virtual machine. And you can do this by clicking on the VM, then clicking on More, then Manage HA. Make sure the request state is started, and then you can click on OK. So now I will open my terminal. I will go to the PM1 SSH session, and I will type the command watch-n 1ha-manager status. And now we'll power off PM3. And we'll watch what happens. First, PM3 will go into a shutdown mode. Then the cluster will report that the connection is dead. And then VM100 will move over to PM1. So first, we'll see PM1 starting, and then we'll see PM1 started. And that's basically how the replication feature works. It's very useful if you want to ensure that your VMs will be online in the event that, let's say, your node has some issues. If you have a critical VM that must always be on, then this is a feature you would want to use. Now, my last test will be to test the RAID feature. Now, currently my two disks are being used in a mirror RAID configuration. I can click on PM1, then I can go to ZFS, click on my ZFS storage, and then click on details. And here we can see my ZFS pool. Below that is the mirror RAID configuration, and below the configuration, we can see the disks that are being used. Now what I will do is I'm going to remove one of my disks, and then we'll see what happens. So I just removed my disk, and now I will click on reload. And we can see that our health is in a degraded status, and the second disk was removed. And even though we lost one of our disks, the virtual machine is still working. Because the data was copied between the disks, losing one disk doesn't corrupt your data. Now let's go to the command line, and I'm in the PM1 SSH session. And here I will type the command zpool status, and we can see the same information from the details tab. I will type lsblk, and we can see the ZFS pool. Now I will add another hard disk to PM1, and now we'll do another lsblk. And now we have a new SDC disk. So we'll use this storage media to replace our currently failed disk and to rebuild our mirror RAID. And before anything, we'll just wipe the disk. So we'll use the command wipe fs-a/dev/sdc. Then I will clear the screen and type zpool status. And the command we're going to use to replace the removed disk is going to be zpool replace ZFS PM, which is the name of my ZFS pool. And then we want the disk that we want to replace. So I will copy the name of the removed disk and paste it. And now I will type /dev/sdc, which is the disk we're using as the replacement. And then I'll press enter. And then we'll do a zpool status once more. And we can see that SDC is now online and it's resilvering, which basically means it's syncing the data and rebuilding the RAID. I will wait a couple minutes and then we'll do another zpool status. And there we go, /dev/sdc has completely replaced the previous failed disk, and now it's being used in the RAID configuration. And if we head back into the GUI, we can look at the details tab for ZFS, and we see the same information. Now ZFS has a lot more commands that you can use, like zpool status will show you basic information, zpool list will show you your available ZFS pools, ZFS list will show you the available data that's on the ZFS pool, and we can see our snapshot here as well. ZFS snapshot is the command that you will use to take a snapshot from the command line. I can type ZFS snapshot, and then I can just copy the name of the disk that I want to snapshot. And then I will add a @before update to name the snapshot. And now I can do a ZFS list-t snapshot, and we can see my fresh install snapshot here, in addition to my before update snapshot. Now ZFS has a lot more commands that you can use. A quick Google search will bring up some useful websites, and I would advise you to play around with these commands in a safe environment. Using virtualization to test this kind of feature is a great way to learn ZFS. And ZFS is actually used in some businesses and corporate environment, so learning this skill will be beneficial for your career as well. And ZFS isn't the only system that uses RAID. There are a lot of storage services out there that heavily rely on RAID. So understanding how RAID works will be a great asset to your skill set. And you can use virtualized disk to simulate different kinds of configurations, and that will deepen your knowledge of this topic. Okay, so that is it for this video. Now, before we end here, let's go through some of the pros and cons of using ZFS. And first, and really the biggest reason, is for data integrity. Basically, ZFS knows when data is wrong and it fixes it automatically. ZFS doesn't just store data, it verifies it as well. Also, ZFS Snapshots is different compared to that of LVMTIN and even QCOW. It's instant, it's recursive, it's easy to roll back, and it's also space efficient. Next is how easy it is to replace a disk. We saw in our example that one of our disks got corrupted, we had to remove it, and we had to replace it with a new disk. And all it took was just one command. And then we have compression. And for compression, the default compression that's used by Proxmox is LZ4. And I know I did manually select LZ4 in this video, and that was because I just wanted to show you how you could change the compression rate if you needed to. But if you just leave it as default, it would choose LZ4 as the compression. And the benefit of using LZ4 is that it saves space, it improves read speed, and it has a low CPU cost. And usually with compression, sometimes it could make your systems a bit slow, but with ZFS, it uses compression so well that it's usually faster, not slower. And also with ZFS, one tool just does everything. It can handle RAID, it can handle disk, file system, volume, snapshot, and replication, and we've seen all of this in action. Now, in terms of cons, the biggest one is going to be RAM usage. Usually you want 1 GB per 1 TB storage. ARC, which is the cache, it just loves memory. You cannot shrink ZFS easily, so your ZFS pools cannot be shrunk. If you made a mistake in your layout, you will have to rebuild it. It's not ideal for tiny builds. If you have like less than 16 GB of RAM with a lot of storage, ZFS could struggle with low resources. Recovering ZFS does require ZFS knowledge. If something breaks, you need to understand how pools work, how dataset works, and how Z volumes work. ZFS can protect you, but make sure you understand how it works. Alright, so that is it for this video. In the next video, we'll look at Ceph and iSCSI. So I will see you in that video. Thank you for watching.